Welcome back to the morning show. It's 6:48 on Wise Guy Wednesday. It's my last Wise Guy segment on the morning show. We've been talking about yesterday and today. I'm leaving the morning show at the end of this week to go to Nightside. And because it was my last segment, Matt's graciously agreed to bring in my favorite experimental tool here, the liquid nitrogen. We have so much fun with this stuff.
And I brought a whole huge bucket of it. So if you want to, pour it into your pockets later and take it home, probably not a good idea. No. So anyways, something about liquid nitrogen. I don't know if you looked any of this up before today, so I brought all the information.
First of all, it's very cold. Obviously, it's liquid air, essentially. What is the actual Fahrenheit temperature of this?
It is 320 degrees below zero Fahrenheit, so minus 320. And the air that we breathe is made of mostly nitrogen, some oxygen, and some other things. And this, of all of those gases, this is pretty much the one that has the lowest boiling point. So oxygen, for example, has a mere 297 below zero. So it will actually liquefy before this stuff does as you cool air down.
So we got a good 30-degree leg up here on oxygen.
Oh, absolutely. So this oxygen, is a mere wimp compared to nitrogen, as go atoms. So anyways, what's in here is a whole bunch of liquid nitrogen. And what you see, when you see the sort of vapor, looks like smoke. It's not really smoke at all. What happens is when you exhale, there's moisture in the air that comes out of your lungs. And so what happens is it's just like fog, and you can explain how that works. When moist air gets cold, the water comes out of gas.
Kind of condenses out.
It condenses out and becomes little water drops. So that what you see right there is really water.
It's a cloud.
Right. And so here, I want you to take this thing, and we're going to do this experiment. You're going to take this thing and just shove it in there as hard as you can.
What we're looking at here is the fact that cold compresses things and makes them smaller. So we're able to shove this big, long balloon.
Right. And so what we're going to see here is that the balloon, take it a little bit at a time, because what I want you to do is to fish the bottom of this thing out here in a second. And so what happens is that the air that's in there becomes a liquid, because this stuff is cold enough to liquefy that air, and liquid just takes up a lot more space, a lot less space. You can pull it out now, and look in the very bottom here. I don't know if you can see it. There's a little
It's kind of hard to see. There is liquid there.
Right. There's a little tiny puddle of liquid, and that liquid is the air that was in that balloon. Now, as this thing warms back up, if we blow on it a little bit, we can get that liquid to
So that's
boil.
Evaporating inside the balloon.
Yes, so this liquid is boiling away, the little puddle is getting smaller and smaller, and the balloon is filling up with air. So what this tells you is that gas at regular pressures that we experience here on Earth takes up a lot less space than liquid does. Right? That's how a steam engine works. You boil water, it takes up space and pushes the piston and stuff like that.
You still feel that expanding, too.
Oh, yeah, it's going to expand, and it's good as new. Now, what we did was, you can probably fish these out. You can use the little things. I stuck a bunch of balloons in here. You can use the tongs to be perfectly safe. Okay, I stuck a bunch of balloons in here before the show, right, to celebrate your... you here.
It's a party in a bucket.
And so what happens is, for some of these balloons, the real long ones, sometimes they get tied in a knot, and when they try to expand back up, they get a knot in them, and they kind of pop, like the one that just attacked me there. And I don't know if that's...
Nothing else in there?
No, yeah, we do have some other stuff. I'll show you how that works in a second.
I can't see because of the fog. So.
Okay. So here's what happens when these things thaw back out. They become big balloons. And so all these balloons, which are obviously pretty big now, were fitted in here just a little while ago.
Now, if we tried to warm these up too quickly because the rubber is rigid, would they pop?
Well, the rubber is pretty flexible, and so it's not so bad. But you can take something else which is rubbery, like this racquetball, okay? And if you stuck one of those in there, which I've already done...
Oh, is that what I'm floating around?
Yeah, you're going to... Okay, let's clear these out of here. Okay, science is messy, isn't it? Okay, so we're going to fish out the racquetball, and the one that's in here is going to behave a little differently. Okay, it sounds different, doesn't it?
Yeah, it doesn't bounce as well.
Okay, now I want you to hit this thing with a hammer. Now, I'm going to put this over top just so it's easier for you to hit it. Give it a big whack. Okay, try it again. There you go.
Cool.
Now, what I like best about that demonstration is the sound it makes.
Yeah.
It sounds like breaking glass or a light bulb or something like that.
But it's actually rubber, and then when this warms back up, it'll be squishy like this again?
Yeah, in fact, rubber's heat capacity and thermal conductivity is such that you can actually pick this up without getting frostbite and thaw it out with your hand, and very quickly the thing becomes flexible again, and it's going to be just as rubbery as the original one was, except it's going to be in little pieces, like a jigsaw puzzle.
Beyond repair.
Beyond repair, totally.
No.
Okay, so you can give that a whack with a hammer.
Well, it's a squishy...
It's a squishy little thing, but come on, you have to do this. Okay, so now that mostly what's inside this little orange thing is water. And so what we can do is we can fish out one that I've frozen. Obviously the water will have frozen this thing. Oh, this one is already broken into pieces. That one you can give a whack. Because this one, I can guarantee, is not going to squish.
So we can break this just like we did the...
Right.
Cool.
So it breaks just like ice, and because this is ice. So every little piece in here, every little piece of orange, which is really just mostly made of water, just like you and I, is rock solid, and when you hit it, it just cracks like an ice cube. So if you were to stick your finger in here, and you see this in some movies...
I learned that last time. That hurt.
Yeah, you don't want to do that.
Okay, so we're having fun with liquid nitrogen this morning. It's Matt Sellon. He's our wise guy. He'll be back more in the next half hour. We're going to have some more fun stuff.
Oh, you're going to do a huge soap explosion the next segment.
Can't go wrong there. It's just past 6:53 and time for a check of